Real quick, getting started, I'd like to thank, and could you all help me thank the sponsors for making this possible and the organizers and staff for actually making this whole thing happen. Real quick, round of applause. Thanks for all y'all. Hey everybody, I'm James. I'm here today to do some coding with you. Specifically, we're going to be talking about refactoring. I'll say that most of what I know about refactoring came to me by way of this clicker that works. Good, it's going super well. OK, came to me by way of these people who wrote this book, and these people who wrote this book. It is my sincere hope that most of the concepts that we're talking about today are not entirely new to you. If you have maybe tried to use some of these, if they haven't really permeated your day-to-day work, if you haven't found the time to practice, or have had trouble putting them into practice in a Rails application of scale, this talk is for you. How many people here have seen this talk, get a whiff of this from RailsConf 16? Good number, not everybody. OK, great. If you're watching this on video at home or otherwise have control of time, feel free to pause me, go watch that, and come back in like a minute and a half. I'm going to do a quick recap for anyone who's stuck in the here and now. Refactoring, what we're talking about today. Here's a definition. It's a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. So a couple important things there. It is purposeful, right? We are making a change to make something easier, and it does not change observable behavior, right? I'm not altering any of the contracts, any user experience in the process of doing a refactor. That's the idea. The big question is, OK, how do you actually do it? And here is the hardest part of the whole thing. If you have code that is in production, if your customers are happy, if your servers are happy, if your error monitoring services are happy, do not touch that code. There is really nothing you can do to improve it, and there's a whole lot you can do to make it worse. What you need to do is wait, and that's super duper hard, but wait until you have a new requirement, right? Once you have a new requirement, you can ask this question. Is your code open for that new requirement? And when I say open, that means something very specific. It doesn't really mean, do I see how I can add this, and I think that I won't introduce any bugs. It means, can I add this new feature by only adding lines, by not changing any existing definitions or methods in my code at all? Right? Is it really open? If it is, that's fantastic. You're done. It's easy. Make the easy change. Move on to the next thing. Right? Similarly, if it isn't, but you see how to make it open, that's fantastic. You're done. The interesting part is what happens when you need to make a change, but your code resists that change somehow, and in a way that makes it not obvious how to proceed. Right? In that case, the refactoring books say what you do is you pick the code smell closest to your new requirement. And this doesn't, again, mean some vague, sorry. Right, a code smell is a very specific thing. It's not just something you don't like about your code. We'll talk about one in a second. But once you find the code smell, you apply a curative recipe for that code smell. One of the key things about code smells is that each one comes with a handful of curative recipes, some process that you can apply to fix it. So you do this over and over again. Eventually, your code is open. You make the change, and you're happy. Right? Sorry. Today, we're going to be talking about a particular code smell called primitive obsession. And primitive obsession is the tendency to use primitive types to represent your business objects. This is a really easy thing to do in Rails. Very often you'll do something like write a user model that has a phone number that's a string. Right? And that's a very reasonable thing to do. In your database, a phone number is a string. But the temptation is to then think of a phone number as being the same as a string. And when you do that, you end up writing code that looks like this, when what you really mean to express is that your phone number is local, right? Like concepts in your problem domain. So we'll look at some concrete examples. The question is, when you find that you have this problem, what do you do? And the nice thing is there are a handful of recipes. We're going to look at two in particular. We're going to look at replace primitive with object, which has this picture in Fowler's refactoring book. It's got some steps. They're broadly make a class, make sure you didn't make any syntax errors, use the class, make sure the tests pass. And a more complicated one, we're going to look at replace conditional with polymorphism, which looks like this. Good luck. Here's kind of what it does to code, if you can see this. You start with some complicated conditional with lots of branches, and you end up with several different classes with simple interfaces and relatively simpler methods. That's kind of the idea. And it has some steps, right? It's create classes for your behavior, create a factory function to pick the right class, yada, yada, yada. The point is not to memorize any of this, right? There are 20-some odd code smells and 60-some odd refactoring recipes. Familiarize with yourself with them, and then go look them up when you need them, right? We're going to dig into these to give you a feel for what they look like exactly. But really, like, don't bother trying to commit this to memory. We're going to try and dig into this in a real, actual Rails application. So we are going to be doing some live coding. Everybody ready? Here we go. OK. So I've cooked up this little Rails app. This is it's an app for managing college records, grades, enrollments, and stuff. A few little domain concepts. I'm going to have to stand by the laptop. Some domain concepts. A section is kind of the core object we're going to be talking about. A section is a particular class, right, like Math 101, running in some term, fall 2019, in some room with some instructor. Students are enrolled in the class, and the enrollment is that join record where we record the student's grade in that class. A couple of I guess sections also do have like student assistance is the idea here. One of the core responsibilities of a section is to decide whether or not it should admit a particular student. And it does some kind of straightforward stuff about checking role and everything. But the interesting bit is it verifies that the student has gotten grades and all of the prerequisites for the course, and that the grades meet the minimum requirements to admit them in. Kind of a core part of the system. Okay? If you can't quite see over here on the right, what I've got running is guard set up with RSpec. So what you'll see, as I change files, I'm going to save this section file. Over on the right, that's going to run the unit tests for the section model. And then, assuming they pass, it'll run the full spec suite. And so I'm going to be making a lot of changes, but I'm going to pretty much ignore that unless it turns red. So if it turns red, we'll, like this front part of the room, please yell at me very loudly and make sure we stop and address it. But otherwise, we're like, yeah, you got me. OK. Otherwise, we're not going to worry about it at all. I encourage you to look away. OK, so one of the other things this app does is we have transcripts. A transcript is largely responsible for computing a student's GPA. It does that by pulling their enrollment grades, looking them up, the appropriate scores for them, and doing some other stuff that's not terribly interesting or important. You can kind of see right here that right now, like our system, it works fine, but it only understands whole letter grades, right? A, B, C, and D. So that's fine until it isn't. But let's say we have a new requirement. We would like our app to support plus-minus grades. We'll work a little bit on defining some acceptance criteria, but let's say when we do that work, we end with a couple specs. This one in the transcript that broadly says, if I have a student who's got all B pluses, I can compute their GPA appropriately. This one fails for not interesting reasons, so I'm just going to skip it for now. You'll see it running as pending in the specs. And then in the section spec, this one that's somewhat more interesting. So I'm going to focus on this for just a second. This spec says if I have a section that requires you to pass a prereq with a C, and a student who has passed that prereq with a C+, they should be admitted into the course, right? Reasonable requirement. This does fail, and nobody yelled at me. Please keep me honest. It does fail, but for sort of uninteresting reasons. It fails because I have a validation on enrollment that says that that's not a reasonable grade. I'm going to cheat just a smidge and add these just so we get to the interesting failure. This one will fail. Don't yell this time. Sorry. If I say it's going to fail, don't, you got it. So we would like for this to pass, but it doesn't. And it's for sort of an interesting reason. Let's dig into the section implementation just a little bit. The issue here is that when I get to the point of checking my requirements, my minimum grade is a C, like you would expect, and the grade that the student has is a C+, which means they should be admitted. But check out that logic on the next line. Sorry, I have line numbers hidden for width reasons. check out the line right below that. The problem here is that when I compare grades, I ask, is the grade that I have before the grade that I have to have, right? And that works pretty well because A comes before C and B comes before C. But the problem is C+ does not come before C any more than Aardwolf comes before A, right? Like, these are strings. And if you take a look at the enrollment grades that we have, right, I have written these down in sort of ascending or descending grade order. But if I ask Ruby to sort them, I get something very different back, right? The core problem is that I have treated my grades as strings. And that was fine to a point, but now I'm understanding that the behavior of a string is different from the behavior of a grade, right? So I have this primitive obsession that I have to untangle before I can move forward with this requirement. So that's what we're going to work on doing. That said, I'm not going to try to actually fix the requirement for a bit yet. So I'm going to comment this spec back out. I expect it to fail. And I'm just going to work on refactoring towards making it open. Right? Thank you. There we go. OK, so now understanding that I have a primitive obsession, I turn towards my recipes. And I'm going to apply extract object for this value. Right? The recipe says what I want to end up with is I want to end up with an object, like a new class, that just has a field that wraps the grade. The code that I want to see looks something like this. I'll wrap the grade. I'll ask for its name back. Right? Super minimal change. That's easy enough to implement. I need a new grade class. I'm going to initialize it with a name, which I store. And I want an adder reader for that name. That's it. Right? But with that implemented, I can change these lines. And it should work exactly as it did before. That's it. We've done a refactoring. That is the entire thing, right? And that doesn't feel like very much, because it's not. But the nice thing is I've made a small but measurable step, and I've accumulated basically no risk along the way, right? I'm going to take several hundred more of these, and by the end, I hope to have something I'm really happy with, but that I never was scared about the entire time, right? So this isn't much of a win, but it does give me a place to start looking towards hanging some behavior off an object that I own that isn't a string, right? So I'm going to carry on and extract that comparison out to an object on the grade class. Again, the code that I want to end up with, like this less than is hugely confusing and hurts my brain to think about. I want to end up with some code that looks like this. Right? Is my grade at least this minimum grade? And that's super easy to add, right? I own the grade class. So if I have some other grade, I'm going to resist the temptation to fix the problem. And instead, I'm just going to move the logic into place. Right? So once that's in place, I can translate that line, and the spec should still pass. Again, I'm going to hide these out of the way. They're not interesting most of the time. I'm really focused on the code change here. All right? And that starts to feel like a win. Right? I am now comparing grades as grade objects. And I could go through my system, and everywhere I make a grade comparison, I could replace it. In fact, I'm going to do that. It's a small enough system that's not terribly hard to do. I just kind of have one other call site, so I can make a similar translation. But what does that really bought me, right? I could do this sort of thing throughout the app. But the problem is I'm still treating a grade as strings everywhere throughout the core of the app, and just at the boundaries where I need to compare them, I'm converting them up to objects. What I'd really like to do is make sure that my system always talked about the objects in my system, right? Like I want all of these, like every time there's a variable named grade, I want for it to be a grade. And then if I update the logic of grades, I'm confident my system works, right? So I want to start moving in that direction. Let's take this as a particular example. I'd like to end up in a world where user.grades returns grade objects. I'm not comfortable making that change, though, because I don't know what all calls user.grades yet. So first, I want to insulate myself from that change a little bit. And I'm going to do that by adding this. So currently, grades is a hash. I'm going to convert all the values to grades. Now, this will fail. Can anybody tell me why? So the tricky bit here is I have basically converted to grades twice, right? Initially, I transform the values, then when I pull the values out of a hash, I pass them through a grade again. So this is not a safe change. I need to revert it. I'm going to back it back out. But I want to head that way. What I need to be able to do this is I need a method of taking a value that might be a string and might be a grade and ending up with a grade. There's a couple ways to do this, but one that I particularly like is to add a factory. So when given a value, I can return the value if the value is a grade. And otherwise, I'll assume it's a string and make a new grade from that value, right? So this works exactly like new, except when handed a grade, I just get the same object back. With that in place, I can update my calls to new with for, confident that if something upstream changes to pass a grade down instead, everything should continue to work as it did before. And then I'll make that change upstream. In fact, I'm going to try to use for consistently instead of new, so that later when user changes upstream from that, I'm also insulated from that change, right? This is just kind of adding a shim layer so that you can be permissive of what you accept in upstream code. Once this is in place, and I know that the grades received from here are grade objects, I no longer need these updates. And I can start simplifying this, this block a lot. I think all of these changes are safe. I'm going to do the same thing in the schedule with the exact same concepts, right? Instead of newing up a new grade object every time, I just want to convert. Then I want to take the upstream grades, in this case, that come from a method on self, and transform them. And finally, I don't think I need that in direction anymore, and can move there. Now, an interesting thing has happened. At this point, if I take a look, I've sort of made a couple of the call sites to grades safe. Let's take a look. If you notice, there are only 3 call sites to grades in my application. 2 that I have immediately cast to objects after calling them, and 1 in specs. So at this point, I'm pretty confident that my app wouldn't change if I changed the behavior of that method. But I should think about what the actual specification says, right? Like, the specs say that I get string-like objects back. It's totally reasonable here to change the specs to reflect the change that I want in the code. But I think it's also reasonable to say, like, my grades are string-like objects, and these specs as written should still pass. I can do that by defining an equals method and saying if the thing that I'm comparing to is a grade, then I check my name against the other grade's name, and otherwise just do kind of the default thing. So I think with that change, the specs should pass, and all of my call sites are safe whether or not I return grades or strings. And I think at that point, I am comfortable making the change to the user grades method to only return grade objects. And all the specs should still pass. Once that's done, I no longer need these shim layers. And now I really feel like I've gotten somewhere. If you look at our implementation of section, as far as section understands the world, grades are grade objects, right? It's not ubiquitous throughout the app, but I have layer upon layer pulled it back and kind of pushed the strings out towards the boundaries. Thinking back towards the requirement, right? My grades need to understand strings. If you think a little bit about the application, right now we're still, our grades need to understand scores. We're still treating a grade as a string in the place where we compute scores, in the transcript. So we'll want to do a similar treatment here, right? But I think we've seen the pattern and we understand the tools. What I want is I want to be able to write, not take the string grade, look it up in a hash. I want to be able to get a grade and ask it for its score. Now, I won't quite be able to do that, right? Enrollment is an active record object. Grade is a string column. But I can at least kind of convert that here for now. And it feels like I should be able to write that. So let's take that as a goal. Right? To do this, grade objects will need to understand their score. Right now, knowledge of scores is wrapped up in the transcript, which is obviously, in retrospect, the wrong place for it. Like this prefix is a clue that grade scores kind of belong on grades. Going to change the name to scores. But with those here, it's easy enough to write the score method. The score of a grade is, well, go look it up. Now, I don't love that it's possible to create a grade that when you ask it for a score, it'll blow up. And I want to fix that, but it's not required yet, so I'm not going to touch it. Right? I'm just trying to get this line, in the transcript, this line safe. And I think at this point, grades have a score method, so this should be safe to change. I will do that. And the spec should still pass. They failed. Did y'all see it while I was doing it by any chance? Grade score. Yeah. I called it scores. I looked up in score. All right, that aside. OK, so that line is now safe as well. And I'm not referencing grade scores anywhere, so I can delete that as well. So this is really good progress, but I think we're at kind of the hardest point and also one of the key points here. If we take a look across the application at the places that we are converting a string to a grade, it's happening in two places. Here in the transcript, we have an enrollment, right, an active record object that's giving us a string. And similarly, in grades, I pull the user's history, and it's still an enrollment record that's still treating grade as a string. If you look at that active record object, we notice that enrollment has its own separate notion of grades. In fact, comparing enrollment and grades together, there's a latent bug here, right? Enrollments can record that a grade was an F, but my transcript has no idea how to handle Fs whatsoever, right? The fact that this logic was written in multiple places has invited a bug. I'm going to call that a bug and just add this, although not prompted by a specific requirement. But in any case, like, we need to unify enrollment with the rest of the system, right? This one's harder, though, because we don't have a grades method to shim. It's provided to us by active record. All right, so we're going to have to do something a little bit fancier here. But similarly, what I want to write is not, like, I don't want enrollment to have its own notion of grades. I want to write something that says, well, the grade for this record is one of the grades, right? For me to treat that field as an object in my domain, I'm going to have to do something special. But active record supports this. I just have to tell it to serialize the grade field as a grade object, right? So this is the goal. I'm going to comment that out for now. There's a couple pieces that we're going to have to implement to make this work. One will need a grade.all method, but that is easy enough to add. Right, I've got my list of scores that I know about. Let's just map over it. These are immutable, so I would memorize that, although it's not strictly necessary. Secondly, if you're not familiar with serialize, the contract that active record expects of you is that the class that you provide to serialize should respond to load, which will get a string and need to produce a string or nil, and dump, which is similar, but we'll need to produce the value to serialize to the database. So we just need to define those. Load a value. If the value is nil, we return. Otherwise, convert it to a grade. And dump is exactly the same, except we need the serialized value, right? In this case, the name of the grade. So with those in place, uncommenting these two lines should work. But we have to think a little bit. There's one change that's latent here. Well, it's not clear. We are changing the contract of the grade method on this object. So we have to think about, are there other places that are calling grade? We saw that we shimmed several of them, but I haven't necessarily audited the whole app to make sure that we have. This is a point where it's really nice to have a good test suite that we can lean on. So I might run this and just see, OK, well, what still blows up there? Otherwise, you can have to go line by line and find every caller. In this case, we should have just a couple. So these are coming from the grades controller, which used to return a string and now is returning name corresponding to a string. Probably not terribly surprising. Right? In my grades controller, I used to return a grade, which was a string. And now I'm getting back kind of a JSON-ified grade object. We could easily add .name here, and that's totally fair. But I think the better observation is to say, right, like anywhere that I'm serializing a grade in my API, I don't want to change anything. I just want to produce JSON values that are just the name. Similarly, with value objects that represent primitive types, it's often reasonable to define a conversion method back to the base type. Right? I think with that change, all of our tests should pass. And they do. OK, so the nice thing here is at this point, now everything in my system that talks about grades uses these objects. So if I want to make improvements to how grades work, I have one file to look at. And I can start to fix it. So one change that I would like to make, although it's not strictly required, it seems odd to me to pass in the name and ignore the score. Like, I really want to think of grades as having a score that I pass in. That is a change to the API for new, so I need to make that a default argument if I don't want to break stuff. And one of the ways that I have found super helpful to give myself confidence that I am free to make changes to that method is, especially if I have a factory method, is to make the new method protected. Right? My expectation is that anytime anyone wants a grade, they're calling for. I can make that explicit by making new a protected method on the class. And then when I do that, I feel much freer to change these implementations. Here, it's easy enough to create a grade with a score. I'm iterating over the list of scores. Here, something slightly different needs to happen. Right? If I'm asking you for a grade object that represents B, something has to know that a B is a 3.0. But really, I think that all should be the source of truth about what grades exist in my system. And I think for should delegate to all. So I would tend to want to write all, find the particular grade that you want, or maybe raise a particular, hopefully helpful error message. At that point, grades have a score. And so I can think about comparing them pretty easily. Right? Ruby gives us good tools for this. If I want to compare two things, I include comparable. I def a spaceship operator. And now, since grade objects have scores, I can easily express that the way you compare to another thing is you compare the scores of the two things as grades. In this case, I'll have to rescue from an argument error if I'm given something that isn't grade-like. Right? But with that in place, so if you're not familiar with comparable, what that does is that gives you greater than or equal to for free. I don't need my equal to method anymore. And finally, and most interestingly, my at least method becomes a lot easier to write. Right? Instead of comparing names, which I know won't work with C++, for instance, I can write this. And while that looks very similar, it is a conceptually very different thing. Instead of saying my name as a string is before some other string, I'm saying me as a grade, I'm bigger than this other grade. All right. So what have we changed here? I contend to you nothing. I contend that nothing about the way the system behaves has been updated at all. But now, if we want to look at our transcript spec, we comment that back in, and our section spec, and comment this back in. For those to pass, we need a B+ and a C+. So they are failing, but I can add a B+ and a C+, and all of the specs should pass. All right? And so this is what I mean. We refactored until it was open for the requirement, and actually implementing the requirement took 2 lines. Right? If you've heard make the change easy, then make the easy change, this, I believe, is what that means. How are we feeling? We good for one more? Cool. Enthusiasm. Thank you. Let's take a look at that grades controller. Right now, when you're checking if you are allowed to change grades, we use the same method in both places. It's this can update grades method, which checks your role in a couple ways. If you're an admin, you can. If you're a teacher, you can. If you're the instructor for a section. And if you're a student, you can't update grades. Student is the implicit third role. I'd like to introduce a new requirement. I'll point out the specs for this are pretty good, and I'm confident in them. So I'll just add this new spec. The new spec basically says, if you're a student assistant, you should be able to record new grades. You can't record your own grade, though, and you can't update other grades, right? So these fail, right? I'll be done when these are passing. To do this, it's easy enough to copy and paste and create a can-create-grades method and then start changing conditionals, right? But my requirement is to add a new role to my system that has new behaviors. And if it were open, I'd be able to do that by adding a new role to my system that has new behaviors, right? The problem is I've tried to represent roles as strings, and so every time I need to make a decision about how they behave, I have to write it right there because I don't have an object to hang that behavior off of. It's another primitive obsession. The way I'm going to fix this is by replacing these calls with polymorphism. I want to end up with something that looks like grab the role for that user and ask it if they can update. Right? So over in the section, I'll start to add that. There's a recipe here. It says define a base class for these roles. Sorry, let me get you some room. Define a factory method that returns the right kind of thing. Copy the method over that you want to extract. Update it appropriately for its new surroundings. In this case, I want to ask, can you update? And I don't have current user, I have user. And then wire that class in. Right, so I want to write this. On my section object, I'll define a role for a user, which returns a role. That's a big enough change that I tend to like to run it once, just wiring it in without changing return value to make sure I didn't introduce any errors, and then running the whole thing. But with that done, assuming the specs all pass, I think we can focus on the role itself. The idea is I want to move this conditional up and give myself different kinds of roles. So I'll start by extracting an admin role. And the way an admin role works is admins can update. Right? That's the business requirement. To make that work, I need to make sure that the factory returns an admin role when appropriate, but doesn't behave any differently in other cases. Once that's true, I never hit that branch, so I can just throw an error there just to make sure for myself. I'm going to extract this new section user bit, just so I don't have to keep typing it. Right? I'm trying to pick the right type of object, but the objects should all behave the same. So that seems fair to me. And I can continue extracting by just defining other roles of other types. Right? A teacher role behaves this way. It's just this logic. You get a teacher role under these cases. And with that in place, I shouldn't hit this branch ever. And finally, while the last role does work, I think in my domain, what's really going on there is a student role which cannot ever update. And so with that in place, I wouldn't implement an update method on the base class at all, or would have it raise some descriptive error saying subclasses should implement this, something like that. But that's my extracted hierarchy, right? Let's pop back over to the grades controller and inline these methods. Right, this is how canUpdateGrades currently behaves. I want to create a new create check. The problem is for creating grades, as an assistant, I'll need to make sure that I'm not grading for myself, so I'll have to pass that in, right? This is the required change. But with this hierarchy, it's easy enough to add. If I want a create method everywhere, I can add it to the base class. By default, the implementation is to check, can I update all grades carte blanche, right? And with that in place, and without the syntax error that I saved, we should be able to make this change, right? None of the behavior has changed. We've just kind of declared these, like pulled them out separately. And again, I have not changed a bit about how the system behaves to this point. But now, if you're handed this and the new requirements, they are straightforward, like almost trivially easy to implement, right? Like there's nothing to do but the right thing, which is if you want an assistant role, we'll make one, define how it works, right? If you're an assistant, you can add a grade as long as you aren't the user you're adding a grade for. And specify the conditions under which that is your role. In this case, it's if the section assistants include the user. With that change, I believe the specs should pass. And again, our implementation of the feature was 5 lines of addition. Well, no. Math, right? 10 lines of added code, didn't have to touch anything else, right? Like we made it open, and then we made the change. Cool. That's it. We did it. We got through it. How are we feeling? Good? Unnecessary. Thank you. So some takeaways from working this way. I think moving towards developing in this sort of mode makes a couple things easy that used to be really hard. You can get started without knowing what the code has to look like when you're done. It is literally a follow your nose sort of thing. You could, like, as long as our tests were green, we could have stopped and shipped to production at any point in time, right? Are you going on vacation? Are you picking up some new task? Are you going to lunch? Doesn't matter. It's good to go, right? It may not have finished. It may not have gotten where you wanted to. But realistically, like, this is software. We're never done. Being comfortable with intermediate steps as being finished products as well is an important thing. There are some hard things that are still hard. One of the key bits here was I got quick feedback. I'll talk through these in some depth. I got quick feedback. That may be hard for you. I would highly recommend setting up guard and spring. You want to run a small set of tests on small objects that don't have to talk to a database. Refactoring will help you get there. Some other things that are hard, working clickers. Trusting your coverage, right? There were some points where it was really helpful to say, like, oh, if something broke, I'll see it, right? No silver bullets here, write more tests. But also consider some in-production testing, especially I've found some science experiments to be valuable, where you can push up a tentative change to production and get some notifications if it actually would have changed anything, so you can be kind of confident that you didn't break behavior. If you're refactoring a lot, you'll want to push hundreds of changes to production that don't change anything. And if you are asking a human who verifies your work to manually regression test every time, you're both going to be miserable. Don't do that to people. If you have QAs, work together to develop a set of regression tests that you're both confident in. Also, give them some insight into your development process, right? Like, refactoring is a process for de-risking the development process. But a lot of times, if you lob code over the wall, people won't see that. Isolate yourself from Rails magic where you can, but don't be afraid to use it when necessary, right? Like, active record is the boundary between the database and your world that you are creating. Teach it about your world so that you don't have to worry about database things. Weirdly, none of this stuff gets harder in larger apps except finding all of the places that you call a method. That's the one thing, right? So if you want to make that easier on yourself, use big, long, descriptive, overly verbose names. Don't get fancy with dynamic sending. And consider maybe like making a new method, switching the callers over, and like deprecating the old one instead of just deleting or rewriting immediately in place. But if I could leave you with like one big takeaway from this, like, how many people have expressed a sentiment like this, right? Like, we have some debt that we'd love to pay off, but we have to ship some features and we're too busy, right? Like, I know I have totally said that plenty of times. More and more I have come to realize that I think that is exactly the wrong perspective. On the one hand, if you do not need to change your product, there is no reason that you should change your code, right? And I mean, like, insufficient performance is a reason. Like, that is a new requirement. But on the other hand, if you need to change your code, why would you ever do that in a way that doesn't make it easier to change, right? It's not that refactoring is the thing that you get to do after your product is done. Refactoring should be the thing that helps your product be easy to make, right? So try folding it into your day-to-day process. Other takeaways, like read these books, they're great. Practice, practice, practice. If your company can bring in Sandy Metz for a workshop, like do that, it's amazing. If you want to work at a company that does that, we're hiring. I took that picture at work the other day. There were dolphins. We also are hiring in Austin, if that's your thing. Go forth and refactor. And that's my time. But I'll be hanging out and happy to chat afterwards.